Okay, guys, I'm going to do some more L'Hopital's practice, L'Hopital's rule practice. Again, so to apply L'Hopital's rule, you should have indeterminate form if you plug in the x value. So if you plug it in here, in this example, we have lim as x approaches 2 of e to the x squared minus e to the 4 over x minus 2. If you plug in 2, you end up getting e to the 2 squared, which is 4, take away e to the 4, which is 0, over 2 minus 2, you end up getting 0 over 0. So here, I can apply L'Hopital's rule. So the idea is, I want to apply L'Hopital's rule in this case, so that I can basically evaluate this limit. So the way you apply L'Hopital's rule, just to review, is basically you take the derivative of the top and bottom. Before I do that though, what I'm going to do is I'm going to essentially rewrite e to the x squared as e to the 2x. Okay, you can do this because e to the x squared can be written as e to the x squared, which can then be written as e to the 2x. So e to the x squared and e to the 2x are identical. Okay, so let's do that. Let me just get rid of this. So let's do that. So let's take the derivative. So I get lim as x approaches 2. Okay, bottom's easy, the derivative's 1. And then here, the derivative is 2e to the 2x. So if I plug in 2 now, I should be fine. I should just get my limit. So the limit in this case is just going to be 2e to the 4. That's my limit. Okay, it's that easy. So let's do a new page, and we'll move on to the next example. In the next example, example 2, okay, let's look at ln of tan x over sine x minus cos x. So if I plug in, and this is lim as x approaches pi over 4. So if I plug in pi over 4, I end up getting 0 over 0. So if that's not obvious, you go ln of tan of pi over 4. Okay, tan of pi over 4 is 1, so you get ln 1. And sine pi over 4 is the same as cos pi over 4, right? So in the bottom, I get the same term, subtracted the same term, so I get 0. On the top, I get ln 1. Ln 1 is 0, 0 over 0. It's indeterminate, so I can apply L'Hopital's rule. Now, what is the derivative, okay? The derivative of tan x. Okay, the derivative of tan is secant squared. Okay, we're going to need this because basically what we're going to do is we're going to do a chain rule on the top. Okay, so it's 1 over tan x times secant squared x. Okay, that is basically the derivative of the top after applying chain rule. The derivative on the bottom is going to be cos x, okay, plus sine x. And now we're all good to go. Okay, so now we can probably plug in pi over 4 and not have any problems at all. So if we do that, let's go. 1 over tan of pi over 4, okay, times secant of pi over 4, and that secant ratio is itself squared. Okay, and then on the bottom you got cos of pi over 4, and you've got plus sine of pi over 4. Now what is tan pi over 4? Tan pi over 4 as we mentioned above, is 1. So I get 1 over 1 times, and what is the square of secant pi over 4? Well, secant pi over 4, okay, is equal to 1 over, is equal to the reciprocal of cos pi over 4. Cos pi over 4 reciprocated is secant pi over 4, and that is the reciprocal of 1 over root 2. The reciprocal of 1 over root 2 is root 2. Okay, so really, secant pi over 4 is root 2, and what I have to do is square that according to this example. Okay, so I'm squaring it. On the bottom, I get 1 over root 2 plus 1 over root 2, and I'm adding those together, and I end up getting 2 over root 2. Okay, and on the top, I end up getting root 2 squared, right? And how does that simplify? Well, after simplifying it, I get 2 on the top because that's the square of root 2. I've got 2 on the bottom, and I've got root 2. Well, these two factors of 2 will cancel, leaving a 1 and a 1. So I end up getting 1 over 1 over root 2, which turns into root 2 as my final answer. Okay, root 2 is my final answer for that limit. All right, so that is the limit of ln of tan of x over sine x minus cos x, and we're going to do one more of these. One more. New page after. So, example 3. Lim as x approaches e, which is like 2.72, of 1 minus ln x over e minus 1. Now, how do we apply this limit? So, if I plug in e, I go 1 minus ln e over e minus 1. On the top, I get 1 minus 1 because ln of e is 1. Okay, 1 minus 1 over 1 minus 1. Clearly, this is 0 over 0. I can use L'Hopital's rule. If I take the derivative of the numerator, I get minus 1 over x. If I take the derivative of the denominator, I get 1 over e. Okay, just 1 over e. Remember, the derivative of a constant is 0. So now if I rewrite this, because I can, I'll get negative e over x, because I'm basically taking this and multiplying by the reciprocal of that. Okay, so then what would I get? Well, now all I have to do is plug in e. So I get negative e over e, and I get negative 1 as my final answer. So this is just some extra practice on L'Hopital's rule. If you'd like to know how to apply L'Hopital's rule, visit my last video right before this on how to apply or how to evaluate any limit in indeterminate form using L'Hopital's rule. It's actually a fun rule. You're just using the derivative of the numerator and denominator, and that's it, basically, until you stop getting 0 over 0. It's helpful to know all the derivative rules, obviously, because I needed to know the derivative of the exponential, I needed to know the derivative of ln, I needed to know the chain rule, I needed to know the derivative of every trig ratio. These are rules that you should be aware of and comfortable with applying. So if you're struggling with that, I would recommend that you practice those. I'll do videos in the future where I actually go through all the derivative rules. But yeah, thanks for watching, guys. Don't forget to like, subscribe, and yeah, have a good one, and I'll see you in the next video. Peace.